such as the different types of energy that you should be familiar with, like kinetic means moving, gravitational is anything off the ground, chemical is usually in batteries and so on. Um, Energy transfers, I'm not going to talk about. Formulas, you might, I don't know if you need to, but generally you shouldn't need to learn any formulae, but that is the formula for kinetic energy. Make sure you know units, like energy is in joules, speed is in meters per second, mass is in kilograms, is important. Gravitational energy also has an equation. Again, just remember any distance is in meters in physics. I'm not going to do that question. Um, nor specific heat capacity. The problem with this page is that loads of it is just equations, and you don't really need to know any. So I will talk about conduction and what conduction is. Conduction is when we transfer heat through solid objects mostly. The way it works is you heat up the particles at one end of the object, they start to move more. When they move, they collide with the particles next to each other. When they collide with the particles next to each other, they gain energy and they start to move more. They then collide with the particles next to them and they start to move more. And that collision thing continues until you get to the other end. So all of the energy is transferred from one end to the other through colliding particles. That's what conduction is. Um, okay, it's when we transfer energy through colliding particles. Convection is another type of heat transfer. I just like to illustrate it with this picture. Um, if you have a radiator in your house, or any heater really, you can leave it in a corner and it heats up the whole room. How does it do that? It's because the air particles near the hot object get hot. Hot things rise just like hot air balloons. The hot air rises to the top. When the hot air rises to the top, the cooler air near the top gets pushed down. That then gets heated up by the hot object, causing it to rise up. And then it kind of continues this cycle where the cooler air keeps getting pushed down and the warmer air keeps rising up, and we call that convection currents, which is what that is. Um, there are things that we do to our homes to prevent the loss of heat. For example, things like cavity wall insulation, which is when you put some sort of insulation between the layers of your walls. What that does is prevents the heat from escaping by conducting through the sides. We don't want our nice warm room for the heat to just leave through the walls. But by putting in some insulating material, what that does, it slows down. It doesn't stop completely, but it slows down the rate at which the heat leaves, so your room stays warmer for longer. Similarly, we can put some loft insulation down, so the heat doesn't go up here and warm up your loft where nobody is. Um, it can sort of trap it down here, keeping it closer to your room for longer, keeping your room warm for longer, which means that you don't need to spend as much money on heating and things stay cheaper. Um, what else? Efficiency, I don't want to do, it's just an equation. And then there's another part of this topic, which I will do to finish. It's a very short topic, but the other part of energy is to do with energy resources and where we get our energy from. The majority of our energy, sadly, comes from fossil fuels, which are non-renewable energy sources. I'm not sure that's where this begins, but oh yeah, it is. Non-renewable energy sources are the three fossil fuels and nuclear fuel. Just be really careful with this. I think a lot of people, when I say non-renewable, they think fossil fuels, coal, oil, gas, but they forget that nuclear is also non-renewable. It's not one of the fossil fuels, but it is non-renewable. It means that once you've used it once, you can't use it again. Fossil fuels, how are they formed? They're formed underground over years and years, over a long time. I'm not sure what the how is for. You said how, as if I meant to know what the how is. What's the how for? Nuclear. Oh, how are nuclear non-renewable? They just are, I'm telling you. Non-renewable means that once you've used that energy source, you can't use it again. Just like if you burn a piece of coal, you can't then, take it off the barbecue and do it all again. Nuclear energy is the same thing. The nuclear fuel that we use, once you've used it, and it can't be used again. So it is non-renewable. That doesn't mean it is. Um, just anybody who's asking about maths, I assume it's year 11 people. If you're an anonymous attendee, I'm going to kick you out in a minute, just to be clear, because I don't want you here unless I know your name. And secondly, I will be beginning some maths in about 8 o'clock. But if you are an anonymous attendee, you will be removed from this meeting, just to be clear. Um, the Non-renewable energy resources are those three. They are coal, oil, and gas. We burn fossil fuels. A lot of people don't get this, but the way we get electricity from burning fossil fuels is we heat it up. We then use the heat sorry, we burn it. We use the heat to boil some water. The water is used, or the steam is used to turn a turbine, which then generates electricity, which is what that is. Is that okay? Um, right. I think what I'm going to do, given that you are asking me irrelevant questions, I'm going to stop this now, given that I was doing this for you. I am going to stop now and be back at 8 o'clock to do some maths. Is that all right? Cheers. Right. What I will be doing to begin. Whoa, go on. Um, right. Okay. Just in answer to some of the questions. Firstly, I am going to do, just because of the variation in people, um, I'm going to start by very quickly going through an entire, I'm going to stick to Excel, even though it doesn't really matter, depending on which exam board you're doing, a foundation level paper. Bearing in mind that the second half of a foundation level paper is the first half of a high level paper. After that, I will focus on some of the specific questions that some people have asked for. Like, oh God, what was it? There were some sequences, there was some circle theorems, and a few other things. The thing with the last question that you've asked about the differentiation and that, I think I'm going to leave that with you till the end because you are probably the only person doing IGCSE. So I will do that, but I will do it separately with you at around 9. That's all right. But until then, it will just be stuff that's hopefully more relevant to everybody. It's quite hard to balance it all. Right. So I'm going to do this really fast, bearing in mind that if you're doing high level, you should know all this like the back of your hand. But still, it'll be useful to do that. I've not seen any of these questions, so I will wing it as I do. And then we will focus on some of the things that I think are harder in the higher level stuff. Most importantly, I want to say this to everybody now who is doing a non-calculator exam tomorrow. This applies to foundation and higher. You must know your exact trig values because that is the only time that this can be tested. It's the only time it can be tested is in a non-calculator maths exam because it's literally the only thing that is specific to non-calculator papers. So if you don't know them now, just spend the evening learning them because it's gonna be on there somewhere. I'll carry on. Work out the range of these numbers. Range means highest take away lowest. 8 take away 2 is 6. Work out 120 take away 89. 31 should be the answer. Okay, I appreciate I've done that quite quickly. Direct and inverse proportion. Yes, sure. It might even come up here. Simplify this. Number 3 times 4 is 12, and then stick the A onto it. Measure the size. Make sure you take a protractor with you to be able to measure things. Protractor and a ruler and a compass. In case you get questions involving loci and construction. Those things require compasses. Okay, I'll see if we come across a question on it, but yeah. Work out a fifth of 300. If you're working out a fraction of an amount, you divide by the number at the bottom and then times by the number at the top. In this case, you don't have to do the timing by the top because it's 1. So just do 300 divided by 5. 5 goes into 30. 6 times 0, 0, 60 is the answer. 3 liters of oil in a can, Germain, uses 700 milliliters. Some conversions. There are 1,000 milliliters in 1 liter, which you might need. That's also, by the way, a meter cubed. Anyway, well, 3 liters therefore is 3,000 milliliters. If you use 700 and you want to see how much is left, you take that away and you should be left with 2,300 without me doing the calculation. Scale diagram, 1 centimeter represents 5 meters. If you draw a line that's 3 centimeters long, then you times it by 5 and you get 15 meters. The real distance is 20 meters. What's the distance on the diagram? So the scale tells you that to go from the diagram to real, you times by 5. So to go from real back to the diagram, you would divide by 5, which means 4 centimeters is the answer. Just keeping an eye on questions. Simultaneous equations will probably come up in a moment. I'm not doing this question, had a waste of time. Except for the word mode means the most common. So once you've done this with your little stuff and all that stuff, whichever is the biggest number, be careful. The value is the mode, not the number. So if these were 10, 5, and 2, the mode is castle, not 10. Okay, so 10 just tells you the position. Sorry, the highest number. Draw a bar chart. I'm not doing that. Selena has a bag of 22 counters. 5 of the counters are blue. 9 of the counters are red. 8 are pink. Takes a random probability, take a red. So if there's 22 altogether, how many red ones goes on the top? That's how you do probability. Does not take a pink. Does not take a pink means not those, but any of those. So 14 out of 22. Don't need to simplify it, so don't bother trying unless it tells you to. Takes a white counter. There aren't any white counters, so the probability of that would be 0. Here are the ingredients to make 20 peanut butter cookies. We want to make 60. The first thing to look at is what is the recipe for and what are you trying to make? Is there a link between those two numbers? Yes, you can times by 3, which means that you times all your ingredients by 3. If he has 900 grams of peanut butter, does he have enough? Well, he needs 3 times as much peanut butter, which is 750 grams. Yes, he's got enough. Draw an enlargement with a scale factor of 3. This is a very easy enlargement question. This is not a typical enlargement question where you have to do a scale factor. Yes, this is foundation. I'm doing foundation first. I'm going through a paper, and then I'll move on to the harder stuff. But the second half of this will be higher level. We're not quite there yet. Scale factor of 3. That. So all you need to do is make everything 3 times bigger, which is so I can't rub this out now. Okay, I'll do it over here. So if that base is 2, then the base needs to be 3 times bigger, so 6. And also the height here is 3, so it needs to be 3 times bigger. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right. Work out the value of P when G equals 3 and H equals 5. G equals 3, I'll put it into there. So that means 2 times G. If G is 3, that means 2 times 3, which is 6, plus H is 5. 4 times 5 is 20. Hopefully the answer is 26. Oh. Okay. Work out the value of G when P equals 38 and H equals 3. So if the equation is P equals 2G plus 4H, when P is 38, I'll put 38 there. H is 3. 4 times 3 is 12. That creates an equation from which we should be able to work out G. You would take away 12. That's what I would do, take away 12. That gives you 26 equals 2G, and then divide by 2, and G is 13. Oh, more. V equals 3R, take away Q. So 3R, if R is minus 3, 3 times negative 3 is negative 9. Remember, when you're multiplying two numbers together, if one of them is negative, the answer is negative. So 3 times minus 3 is minus 9. Minus Q, Q is 2, minus 9 minus 2 is minus 11. Use a number line if you're not sure. At this point, I believe we are drifting into what would appear on the high level paper from memory. Chloe is making scrunchies. Chloe has a large number of hairbands. Each hairband costs 8 pence. She buys 100 grams of wool for £3. She uses 1 hairband and 5 grams of wool to make each scrunchie. She makes as many scrunchies as you can. Work out the cost. Okay, fine. If we're using 5 grams of wool and we've got 100 grams of wool, it means that we can make 20 scrunchies, right? If we use all of the wool. Okay. So that's how many we can make. And we'd need 20 hairbands as well. Just bear in mind because we're making 20. Okay. Is there another way to do this? Yeah, no, we can't do it like that. No, yeah, we can. Yeah, 20, fine. So we're making 20. The question is work out the total cost of each scrunchie. Well, one scrunchie has a hairband, which costs 8p, and then 5 grams of wool. So actually, I want to change how I did that. I'm going to say 100 grams of wool cost me £3 or 300 pence, if we want to just keep it like that for now. If we're using 5 grams of wool, then basically, I mean, you could just do this really, really slowly and say, well, 10 grams of wool must cost 30p. So 5 grams of wool would be half that, which is 15p. So it costs 15p for that 5 grams of wool, 8p for the hairband, which means that the total cost of each scrunchie is 15 plus 8, which is 23 pence. That would be the answer. Okay. Drawing a line y equals 4x minus 1 that people seem to struggle with. If in doubt, make a little table like this, x and y. Put in these x values. It tells you from -2 to 2. Okay, minus 2 to 2. Um, and then what you do is you use this equation, because an equation of a line is like a number machine that you put in values and you get out values. You can put in all of the x values and get out the corresponding y values. If we do it for the easy ones, 0, if we put x as 0 in there, that's all 0, take away 1. So y is minus 1. When x is 1, it's 4 times 1, which is 4, take away 1, which is 3. This is going to be 7. This is going to be minus 5. This is going to be minus 9. I know this, by the way, in case you want to, for slightly more advanced people, that because that number is a 4, I know this is going up in 4s every time. So you literally can just do it once and get all of the other values by keep adding 4, because that's what the gradient is. It is how much y goes up by for every x value. So you could just literally do it once and then get the others quite easily. And then plot them. Minus 2, minus 9 is down here somewhere. Minus 1, minus 5. And once you've done a few of them, you kind of don't need to do any more. Just draw a line through them. Yeah, and then draw a line through them, something like that. Steve is buying a car. The car costs £12,000. Another question here. Lowest common multiple and highest common factor. Yes, very exciting questions. Steve is buying a car. The car costs £12,000. Steve pays 25% as a deposit. The deposit is what you pay up front before you can get it. And then you pay the rest off in some monthly installments. So we need to figure out how much each monthly installment is. We can't do that until we figure out how much you've already paid. So you've already paid 25%. 25% is a quarter. Quickly to find a quarter in a non-calculator exam, half it, then half it again. That gives you a quarter. Half of 12 is 6. Half of that again is 3. You pay £3,000 as a deposit, which means you've still got £9,000 left to pay. If you're going to pay that off in 20 monthly payments, you need to divide this by 20. I would just do it like this. 20 goes into 94 times, remainder 10, because 20 times 4 is 80. 20 goes into 105 times, and it goes into 0 times, which means that each monthly payment is £450. Someone takes an exam. The exam is out of 60 marks. They need to score at least 70% of the marks to pass the exam. He scores 45. Show that he passes the exam. We need to basically figure out what 70% of 60 is, which you might just be able to do in your head, because 10% is 6. So 70% is 42 if you just times it. So therefore you've done it, right? But 70% of 60, if you want to do it the slow way, then 10% is 6 and 70% is that times 7, which is 42. So you've made it clear that you need 42 marks to pass the exam, and they got 45, so they passed it. Congratulations. Work out 3/5 divided by 1/6. Dividing is times and flip over. Please don't forget these things. And then 3 times 6 is 18. 18 over 5. You got to give your answer as a mixed number. How many 5s go into 18? 3. Remainder 3 over 5. This is why you need to know your times tables. Work out 6.3 times 2.4. If you get a question involving multiplying decimals, what I do, it's up to you if you want to do this, is I ignore the decimals and do the calculation. Right? I think I can't remember how most people do this. Most people do this by doing 3 times 4 is 12. 6 times 4 is 24, and 1 is 25. Then they put a 0. Then you do 3 times 2 is 6, and 6 times 2 is 12, and you add them together. And you get 1, 5, 1, 2. Once you get 1, 5, 1, 2, you then need to just figure out where the decimal point goes. One way of doing it is to count how many numbers are after the decimal point in the question. There are 2 numbers after the decimal points in the question, which means there need to be 2 after the point in the answer, and therefore the point will have to go there. Another way to think of it is that roughly this question is 6 times 2, isn't it? Roughly. 6 times 2 is 12, right? Roughly the answer needs to be close to 12. Like it can't be, I can't put the point there because that cannot be correct, because it needs to be around 12, the answer. 151.2 is way too far away. It can't be 1.512 because that's too small. It needs to be around 12. The only place where it can be sensible is if it's there to get 15.12. So you could just sort of go with it in terms of what you think. Write down the value of 5 to the power 0. Anything to the power 0, the answer is 1. Anything. Negative indices now. When you have a negative power, What it does is it flips over the big thing. So if it's a fraction, then obviously it just flips it over easily. If it's a whole number, just remember any whole number is technically over one. So you just flip it over. 1/5, right? The two is still there though. What the two is doing now is squaring everything. You square the top and you square the bottom. The top squared is 1, the bottom squared is 25. That is the answer to the question. Write this in that form. On the top here, do that first. We add the powers together to get 2 to the power 9. On the bottom, we subtract, well, sorry, no. Now we subtract the powers. 9 take away 3 is 6. So the answer is 2 to the power 6. Product, this might be a lowest common multiple question. It is. Highest common factor. Right, 156 is a product of its prime factors. Okay. Geez, that's annoying, isn't it? 78. Yeah. 78 and 2, I think. Yes, it is. Right, that's a prime number. And then 78 is just 39 times 2. It's a horrible one, this. That's a prime number. 39 is 13 times 3, and they're both prime numbers, which means that 156, the product of its prime factors, is 2 squared times 3 times 13. That's it. Right. The reason they've asked you to do this, just so you understand, is that this is how we begin to do lowest common multiple and highest common factor questions. If you can write, if you've got two numbers and you got to figure out what their highest common factor is or what their lowest common multiple is, if you do this tree diagram, this thing for both of them, it becomes quite easy to do a highest common factor or lowest common multiple question. And this is the next question. So we have already done the 156, right? That was the previous question. So 156 is 2 squared times 3 times 13, right? We've done that. I need to do the same for 130, so I'm just going to do that over here. 130 is 13 times 10, which is 2 times 5, and 13 is a prime number as well. So 130 is 2 times 5 times 13. Okay, at this point now, let's pretend that this was a two-part question in which you had to find the highest common factor and lowest common multiple. Lowest common multiple would be huge. But anyway, let's pretend we had to do that. You wouldn't have to because the numbers would be too big. But let's pretend that you had to find the highest common factor and the lowest common multiple of 156 and 30. First thing you need to do is draw a bit of a Venn diagram. One which is for the factors of 156, one which is for factors of 130. First thing you do is write down in the middle the factors that are common to both of these out of what you have done. So for example, both of them have got a 2 and a 13. Okay, both of them they're the only ones that are common. Now the 130 also has a 5, and the 156 has another 2 because this was 2 squared, and the 3. Is that okay? So that's got all of them. Now, if you want to find, if once you've done this correctly, very important, then to find the highest common factor, you just multiply together the numbers in the middle of this diagram. So the highest common factor is 26. Okay, that's the highest common factor. If you wanted the lowest common multiple now, you multiply together all of the numbers in this diagram. So that would be 2 times 3 times the 2 times the 13 times the 5. What's that? 6 times 2 is 12 times 5 is 60. 60 times 13. I don't know what that is. Don't know what it is. But anyway, that's what it would be. That's what the lowest common multiple would be. So that's why these diagrams are so helpful. If you draw a factor tree for the two numbers, and to get these out, draw your Venn diagram correctly, that is important. Then the numbers in the middle multiply together to give the highest common factor, and all of the numbers multiply to give the lowest common multiple. Okay, the reason this works, just so you understand, is that we're not double counting these numbers. Otherwise, somebody might say, can't you just times them all together? Like that you had from the beginning and to get the lowest common multiple. Well, that would give you a multiple. It wouldn't give you the lowest multiple. The lowest multiple needs to exclude the numbers that are counted twice, the 2 and the 13. So by drawing a Venn diagram, you don't count these numbers twice because you've only written them once, if that makes sense, because they're overlapping. That is that. Hopefully that answers one of the many questions. Very common question, whether on a calculator or a non-calculator paper, really. At both foundation and higher, I should make that very clear now, because we are well into this. The mean length of 5 sticks is 4.2 centimeters. To calculate the mean, you add up some numbers and divide by how many numbers there are. That's what you do. You add up some numbers, you divide by how many there are. Sorry, how many there are. In this case, they have told you the mean is 4.2, and we know there's 5 sticks. With that information, I can work out what all of the length, these are the 5 sticks, right? I can work out what the lengths of all of the sticks add up to. Yes, if you want to send some questions on Thingy, yes, please send it. If you multiply these together, you could work out what the lengths of these sticks adds up to. So 4.2 times 5 will give you the sum of the lengths of those 5 sticks. It won't tell you what they're all individually are, but it'll tell you what they all add up to. 4.2 times 5 is, again, if you, for non-calculator tips, if you're timesing by 5, what you could do is times by 10 and half it. So if you times by 10, you get 42. If you half it, you get 21. 4.2 times 5 is 21. That is what the lengths of the sticks add up to. Now, one of the sticks was 7 centimeters. We need to find the mean of the other 4 sticks. So we're going to get rid of the 7 centimeter stick from these 21. But if you take that away, you get 14. That's what the other 4 sticks add up to. And there's 4 of them. So you do 14 divided by 4, which is 7 over 2, which is 3.5, as the mean of the other 4 sticks. Turned out it was not 7 centimeters long, it was 17 centimeters. How does it affect your answer to part A? I think it makes your answer to part A lower because if they all added up to 21, and now this stick is 17 that you took out, it means the remaining sticks only add up to 4 centimeters. So their mean is going to be a lot lower than that, basically. Um, dum, dum, dum. Right, okay. This is why I said you need a compass. For this kind of question. Use ruler and compasses to construct an angle of 90 degrees at P. I think I know how to do this. It's called a perpendicular bisector. That's what we are drawing, or a perpendicular line from here. Okay. I think what I would do is as follows. Measure a certain distance from your compass. Put the sharp bit of your compass there. Stretch it out a little bit, let's say to here, right? And then draw an arc here, and then draw an arc the other side as well. So these should be equal distance apart. They're not quite at the moment, but let's say they are. Then stretch out your compass a little bit more. Put your sharp bit here now and draw an arc, and it'll look like this, something like that, basically. And then put your sharp bit there and do the same thing, and you will get something that looks like that. I'm trying to make it look right. Okay, it'll look something like that. Okay. And then what you do is draw a line straight from there to there, and that is a 90-degree angle. Essentially, the markers are looking for the arcs. So what you can't do is get your protractor out and measure a 90-degree angle, even though that would be the logical thing to do. You need to show these lines, these arcs. So even if you do exactly what I just did, you probably get all the marks without actually doing anything. Okay. The diagram shows an isosceles triangle, ABD, and the straight line ABC. BA equals BD, right? So that line is the same as this line, which means that this is an isosceles triangle where these two angles are the same. So that's also X. Now, it tells you, now what do we know about these three angles? We know that x plus y must equal 180. Okay. But we also know that x to y is in the ratio 2 to 1. What that means is that x is exactly 2 times bigger than y. Sometimes it's helpful to write ratios on top of each other. Actually, no, it's not. But anyway, what we're saying is that x is twice as big as what y is. Okay. Um, Somebody asked me a question. Um, Decimal into fraction and a fraction to decimal. I shall do that in a second. Um, so we know that x is effectively 2 times bigger than y. You see that? Like if y was 4, x would be 8, and so on, right? So since x is 2 times bigger than y, that's what we have just deduced from the ratio here. Um, that means that I can go, okay, well, if x is 2y, why don't we just change this x to 2y? So if that was 2y, then 2 times 2y is 4y. 4y plus y is 180 now. 5y is 180. And y is 180 divided by 5, which is 36. Um, but do that yourself if you're not sure. That means I figured out that y is 36. I don't even need to work out what x is actually, but I could, because the question says work out w. W and y add up to 180 because they're on a straight line. So you do 180 take away 36 now, and you will have your answer. Um, this person, the question before this, someone wants to see. I don't know what that was. Was that this one? Yeah. Right, that's enough. It's all on YouTube. Watch it later. Right. This person has 3 shelves of books. Visuals can be helpful. There are X books on shelf A. There are 3X plus 1 books on shelf B. There are 2X minus 5 books on shelf C. There is a total of 44 books on the shelves, which means that these three values or expressions add up to 44. So X add 3X add 1 add 2X minus 5 makes 44, which means that you should be able to figure out what X is. So X add 3X is 4X, add 2X is 6X. 1 take away 5 is minus 4. Add the 4 to get 48, and then divide by 6. 48 divided by 6 is 8. X is 8, which means that there are 8 books on this shelf. 8 times 3 is 24 plus 1, 25 on that shelf, 11 on that shelf. If you just sub in x equals 8 into all of those. And then it says the books on shelf B have a total mass of 7,500, and all the books have the same mass. Work out the total mass of the books on shelf A. Hell. Okay, there are 25 books on shelf B. They have a total mass of 7,500. So each book is 7,500 divided by 25. Because, yeah. And 25 goes into 75 3 times and then zeros. So each book is 300 grams. The question is work out the total mass of the books on shelf A. There are 8 books on shelf A. Each of them is 300 grams because they all have the same mass. 8 times 300 is 2,400. Just check it in grams. Don't be stupid otherwise. Grams. Done. Formula. You don't need to learn anything really, but I feel like this one you do, which is that density equals mass divided by volume. Your formula sheet doesn't have this on it, yet I see questions on this frequently. And I mean, that's it really. We've done it. Density, if you know the equation, that makes it easy. Density is the mass, which is 27, divided by the volume, which is 10. Just to make sure the units are the same as the units in the answer. 27 divided by 10 is 2.7, and you have 2.7 grams per centimeter cubed. Work out an estimate for this. This is how I would do it. There are lots of ways to do these. But all you have to be careful with these kind of questions is that you don't round too much and therefore get too far away from the answer. For example, I wouldn't round this number to 10, even though it is close to 10, right? But I feel like if you go to 10, you're going to get too far away from the answer. And so what I would do personally is round this to 6. So it's 6 times 8. And the bottom, I would round to 0.25. Although I reckon if you round it to 0.3, you'd be okay. So this becomes 48 divided by 0.25. That is dividing by a quarter. Dividing by a quarter, if you remember from your knowledge of dividing fractions, is the same as timesing by this flipped over. So dividing by a quarter is the same as timesing by 4. So 48 times 4 is what I need to do. And I think the answer is 192. And I think that would be fine if you did that. I don't know what you mean by the Venn diagram annotation. Oh, those things. Those things. Is that what you mean by the Venn diagram annotations? Let me know. Yeah, depends what you mean. Expand and simplify. Um, Yeah, I mean that if it's literally that, it just means that everything in the Venn diagram, that's all that means. That means everything. So when you have a Venn diagram, then you have this there, which just means in this diagram, we have all of these numbers. So they'll sometimes say that that is 0, 1, 2, 3, 4, 5, and 6, which means that we have 0, 1, 2, 3, 4, and 5, and 6 in this diagram. And then they're all in here somewhere. And then the other bits of it, I'll come, and then I'll just explain this quickly. So when you have this symbol on a Venn diagram question, it means I think of it as an and. So if I say to you A and B, sorry, we're off topic here. If I say to you A and B, then I'm talking about this section here, which is the overlap of A and B. If I had said that, which is A, I think of it as A or B. That's what I think of that as. I think of that as an or. Then what I'm talking about is all of this, this, and this. That's it. So that's the difference between those two. So if it's the N, I think of that as an and, so it's only both of them, so the bit in the middle. If it's that, it's both of them. And if you have these little things like that, if I said to you not A, would be anything outside the A circle, so that would be all of this. And if there's more numbers, then all of the numbers outside here as well. So that just means not what's in the A circle. And they're the only three things. Let's get back to it. We'll see some other ones. Expanding the brackets. That times that is 6x squared. That times that is minus 15x. That times that is plus 4x. That times that is minus 10. There should be 4 multiplications that you do when you're expanding the brackets, and the bits in the middle should simplify a bit. Minus 15 add 4 is minus 11. Okay. Factorize this. Look out for this. It'll probably be on a non-calculator paper as well, this thing. It's called the difference of two squares. This factorizes to, what you're looking for, just to be clear, is a minus, a square number, so something squared, that's 4 squared, and another square number, that's obviously x squared, if you see what I mean, right? And so when you have that, you have something squared minus something else squared, you can turn it into 2 brackets with a plus and a minus, where you have the square root of one of them, so x, and the square root of the other one, square root of one of them and the square root of the other one. That becomes x plus 4x minus 4. Similarly, x squared minus 25 would be x plus 5, x minus 5. Slightly more complicated example would be something like, well, quite a lot more complicated, would be something like 4x squared minus 9y squared, and factorize that. You should, what you're supposed to recognize is that this is 2x squared. That makes 4x squared. This is 3y squared, which means that this can be factorized to 2x plus 3y, 2x minus 3y. That would be how that could be done. Okay. And that was all of that foundation level paper. I am now just going to focus on some of the other questions that have been asked. Oh yeah, there was one more thing. Sorry, somebody asked me how do you convert normal decimals into a fraction? Well, decimals to fractions is I think really simple. If I've got 0.2, then you take this number, put it on the top, and on the bottom, you put a 10 if there's only one number after the point. If there were two numbers after the point, you take all of this, put it on the top, because if there's two numbers at the bottom, you put it over 100. So 25 over 100. If there were three numbers on the top, you take all of them for the top, 253, because there's three digits after the point, it's 253 over 1,000. That hopefully explains how to convert fractions to decimals. And then, sorry, decimals to fractions. Fraction into a decimal. I will just do it with one example of 3/8. So if you had to turn 3/8 into a decimal, and you didn't know, then you should write it like this: 3 divided by 8, 3 inside, 8 outside. Put a point there, put a few zeros in. You might not need all of them, but put a few zeros after it and put a point above. And then do it like a normal division, which is 8 does not go into 3. So 0, remainder 3. 8 goes into 33 times. 8 times 3 is 24, remainder 6. 8 goes into 67 times. 8 times 7 is 56, remainder 4. And 8 times 5 is 40. So you stop when you get an exact one. You will just turn 3/8 into the decimal 0.375. Oh, if it was 2.5, right. Oh, it's fine. If it was 2.5, you do the same thing, actually. You take the whole number, 25, and if there's only one number after the point, what do? You put a 10 on the bottom. So they actually follow the same thing. So the rule is take the whole thing, put it on the top. So if it was a 0, obviously you're just putting 5 on the top. But if it's 2.5, put 25 on the top. And then all you do is count how many numbers are below the how many numbers are after the point. And if there's one, you put 10 on the bottom, and so on and so on. I'll do one simultaneous equation because it didn't appear on there, given that people seem to be clamoring for simultaneous equations. Okay. I can't really make one up, can I? No. We'll do a relatively normal one like that. Right. This is a simultaneous equation question. Oh, did you send a simultaneous equation question? Oh God, 4.625. Take the whole number, 4,625. How many numbers are after the point? Three. So you put 1,000 on the bottom. Done. Okay, that's not a simultaneous equation question that they're asking for, just to be clear. That's not. This is a simultaneous equation question that is a linear simultaneous equation, which is different to a quadratic simultaneous equation question, which I'm not going to do only because I need to focus on non-calculator stuff for now. That's my only problem with it. So some of those questions that you sent, I might not do them only because I need to focus on non-calculator stuff majority. Um, so just one more thing. If I want to do something now. Ooh. Right. I will do one because somebody else did ask about this. So with simultaneous equations, either you need to make the x's the same or the y's the same. What I'm going to do is make the quickest way to do it is to times this top equation by 2. That will give you 6x plus 2y equals 30. And then 5, the bottom one stays the same. Subtract the equations. because you've made the y's the same. What you're trying to do is get one of the letters to disappear. 30 take away 24 is 6. 2y take away that is nothing. 6x take away 5x is 1x. So x equals 6. Once you've got x equals 6, go back and find the y by subbing it in. So 3 times 6 is 18 plus y is 15, which means y must be -3. That's what that must be. Um, go back to the last question. I don't know what the last question was. The last question on the paper. I don't know which one you mean. You tell me. Decimal to fraction, sorry. Decimal to fraction. I don't know which one it was, but um, all of that. No, I thought I did one more anyway. Yeah. Right. What else do I need to do then? Let me just see what I was sent first. God, you only send me really hard questions. Um, okay, what I'll do is I'm going to do one of these that you've sent, but only it's technically a calculator question. That's only because of the ending, so I will just do it. So I'll say this is now I'm just focusing on fairly higher level stuff at this point. Um, so for example, there is a topic called quadratic simultaneous equations where you get things like this and this. And what you need to do first when you do these questions is with the easier equation, we call that the linear equation, change it to make one letter the subject. So the easiest way to do that is to make y the subject and move the 2x to the other side. So it's minus 2x plus 3 or 3 minus 2x. And then take that and sub it into where the y is in the other equation. So you've got x squared plus the y is being changed to minus 2x plus 3 squared equals 20. Then that's the first thing to get right. And then it's a case of now expanding these brackets out, simplifying it, and you'll end up with a quadratic equation that you have to solve. So um, if you square the first, if you expand these brackets out, however you do it, write it out twice, do it, just be careful. But minus 2x all squared is 4x squared. Minus 2x times 3 is minus 6, double it, minus 12 plus 9. That's what it's going to expand to, okay, that bracket equals 20. Simplify, x squared plus 4x squared is 5x squared, minus 12x plus 9 equals 20. You'll then subtract the 20 because to solve any quadratic equation, you need 0 on one side. 9 take away 20 is minus 11, at which point I'm going to stop. Because if you get this far, you then need to solve this quadratic equation. Now, this particular question was on a calculator paper, which means that you, and it said actually, solve it, give your answer to 3 significant figures, which means the only way to solve this quadratic equation is to use the quadratics formula. Now, you are unlikely, well, not even unlikely, in this question, definitely not going to be using the quadratics equation on a non-calculator exam. But if you were, A is 5, B is minus 12, C is minus 11, then you should be able to get that. Um, yeah, ratio. Well, the problem is there's no such thing as a ratio question because it's too there's the most varied things in the world. I will see if I can, but as I say, if it comes up, it's likely to be fairly high level stuff that I'm going to do now. Um, even though this is a ratio question I'm looking at, but it's not quite the same. Let me see if I can figure this out in my head. Okay, I will try and do this question. I might not be able to do it, but it says that there's some points A, B, C, and D that lie in order on a straight line. And it then says that A, this is quite a hard ratio question, just to be clear. AB to BD is 3 to 5, and AC to CD is 5 to 6. Now, instinctively, I think I know what to do, but okay. It tells you that AB to BD is in the ratio 3 to 5. Okay. And then it tells you that AC to CD is in the ratio 5 to 6. I hmm. Instinctively, I don't know if I'm probably not going to do this. It'll take me ages, but instinctively, I don't even know what the question is. What was the question? The question was to find A, B, B, C, C, D. Okay. So we need to know what B to C is. Instinctively, I'm thinking that when you have ratios like this, you kind of want to make them into common numbers, as it were. And I noticed that 30, they all go into 30. So I'm going to times, what do I do? I want to turn the fives into 30. Is that what I want to do? Um, that doesn't really help. If we just try and do that. Won't help in the slightest. Um, I don't know if this is the answer, but no, I know what I needed to do. Sorry. 8 and that added up to 8, that added up to 11. That's it. So, because adds up to 8 and this adds up to 11, it is easiest if you change them both into a common multiple of 11 and 8. So I'm going to make them both 88 effectively by timesing this one by 11. So that'll be 33 to 55. And timesing this one by 8. So that's 40 to 48. And then we've basically done it. Because now, essentially, you see the distance here now, 55 and 33 add up to 88, and 40 and 48 add up to 88. So now you can sort of effectively figure out what each little bit is. So B to C must be 7. Yeah, it works. Right? Because it's like the difference between 40 and 33. And then if that's 7, then C to D is 43. Sorry, not 43, 48, which is what we expected it to be because we know it's 48. So essentially, AB is 33, BC is 7, and C to D is 48. A ridiculous question. But that would be the answer to that question. Took me a while. Um, Right. Anything else? Anything else? Anybody? Anyone just fire some things at me? I need to go back and look at all of these. Um, direct and inverse proportion. Somebody had asked me for, so I want to do that. Um, I will find it. Okay, there's quite a lot of variation of these proportional questions. I'm going to do the one that's sort of the classic question where you have to work out this K business. Um, right, here's a question. G is directly proportional to the square root of H. Um, circle theorem's proofs. Yeah, amazing. I'll get to all of that. G is directly proportional to the square root of H. Directly proportional. You don't even need that symbol. I mean, you can write that if you like, but directly proportional basically means that this equals something times this. Okay. And we often use the letter K, but you can use whatever letter you like. K times the square root of H means the square root of H like this. Okay. That's what directly proportional means. If it had said inversely proportional, all you do is you do that K divided by the square root of H. So directly proportional means K times the thing you've got. Inversely proportional means K divided by the thing you've got. In this case, once you've got here, they will always give you some information, some useful information, which will help you work out what this K is. When G is 18, H is 16. The square root of 16 is 4, which means 18 equals 4K, and K is 18 over 4. Bear in mind, I don't know if this is on a non-calculator or a calculator paper, but it doesn't really matter. So 18 divided by 4 is 9 over 2, which is 4.5. So K is 4.5. Now that we know that, what I always do is rewrite the original equation, replacing the K with the thing we've just found. And then we can answer any questions. Find the possible values of H when G equals 2. So if G equals 2, this would be a calculator question just because of the numbers, but it doesn't change anything. If G is 2, you then divide by 4.5, and then you square both sides. So that would be your answer for this question, only because this is a weird one. Not weird, it's just more of a calculator question. I'll just do one more, which is the inverse proportional. Then I will also do some circle theorems. Again, circle theorems, and especially circle theorems proofs, which has been asked, is again, I always say these things probably more likely to come up on a non-calculator paper. That doesn't mean that they are exclusive to non-calculator things. Anything can come up anywhere, with the exception, I'll go back to it from the beginning, the exact trig values. That is something that can only be asked in a non-calculator paper because you have a calculator otherwise. So make sure you've learned them. Things like sine 30 as a half and sine 60 is root 3 over 2. I don't even know them, but you do need to know them because you have an exam. Y is inversely proportional to X. That means that Y equals something divided by X. That's the inversely proportional, means equals something divided by. When Y is 15, X equals 4. They give you this information to help you work out the K. When Y is 15, X is 4, which means K is 15 times 4, which is 60, which means that now I can rewrite this equation as 60 over X. And then I can answer any question they ask me, like what is Y when X is 12? Well, if X is 12, Y is 5, because 60 divided by 12 is 5. And that is direct and inverse proportion. Um, Wait, let me just check because I had an email as well. Vectors proving a straight line. I'll do that. So I'll do the circle theorems, then the vectors on straight line, and then these geometric sequences, although that is a rare topic. Um, but I'll do it. I'll have to make it up, but I'll do it. Right. Where are we? Circle theorems. Okay. So what I'll do first, very quickly, is recap the circle theorems. Then, in higher level, there is one fairly horrible topic to do with the proof of the circle theorems. You may get a question on it. It will probably be worth 4 or 5 marks. It's life. Right. So circle theorems. Rule number one is that if you have an arc AB and you have the middle of the circle there, for example, then if I make an angle at the middle of the circle from that arc, let's say of 100 degrees, and then from those same 2 points, I make an angle somewhere else, the angle is that is half that, basically. Okay. The circle theorem, as I hope everybody knows, in principle, when I do it like this, it's really easy. But when you see it all at once in a question, it is admittedly harder. Right. There are 2 points on a circle, same arc thing again. I make an angle from there with those 2 points, and then make another angle from the same 2 points. That means that these two angles must be the same. And also, just bear in mind, if you look at this upside down, head's not changing. Anyway, look at it upside down. Then this angle here must be the same as this angle here. Okay, so that is that one. The next one is when you have the middle of a circle and a line going through it. If that line from the point where it meets, we call that a diameter because it's going to the middle, makes an angle somewhere, the angle it makes must be a 90-degree angle. We will prove that one in a moment. The other one is a cyclic quadrilateral, which is a four-sided shape inside a circle. The opposite angles add up to 180 degrees. We'll prove that in a minute. Maybe. What else? Oh yeah. Generally, any circles theorems question usually has some hidden isosceles triangles. Hidden. That's not a circle, obviously, but let's pretend it is. That's the middle of a circle. If I draw a line from there to there and a line from there to there, they are both the radius of the circle. If I then join this up like this, I have made an isosceles triangle, even though they will not put these lines on there. Just make sure you look out for that, okay? So hidden isosceles triangle because that is the radius and so is that. That means that this is an isosceles triangle, so the two angles at the bottom are the same. Okay, just give me one moment. Right, I'm going to pause just for a moment. Just give me a second.